Based on your time zone, good morning, good afternoon, and good evening. My name is Petr Nemeth, and I'm the CEO of Dataddo, and I would like to welcome you on today's webinar, which topic is no-code CDC-based database replication. So before let's say we allow others to actually join the webinar, let me do some housekeeping here, because just to make sure that we put the things into order before we start. So of course you can actually ask questions during this webinar. So whenever there is something unclear or you need to clarify something, feel free to ask questions, and there will be, at the end of this webinar, there will be a room for answering your questions. But of course, in case you will not be able to ask the questions during the online session, feel free to reach out to my email address, and I can answer those questions in the offline mode. So I guess we can start. So our topic today, as I already mentioned, is no-code CDC-based database replications. So the important questions at the beginning is why would you consider to actually deploy a CDC-based data replication? And there are a couple of use cases when we see it's actually common to use this kind of technology. The first is which is most relevant to what we will be calling today, and it's all around business intelligence, data warehousing, and analytics. So the typical case is you have some production database. So you have a system, you have an application, you have an e-commerce store, where you have actually extremely valuable data to your organization. So let's say in case you are a e-commerce company, you have there all the information about your transactions, your customers, invoices, payments, the kind of purchasing behavior. And of course, this is extremely important source for your business intelligence and analytics initiatives. But of course, on the other side, this actually sits in the production database. So what it means, if you would run a couple of extremely expensive queries, like those that you specifically need for the analytics. So we are typically talking about the queries where you need to do a lot of joins. You need to perhaps run a couple of transformations. You need to do all the things like grouping, window functions, and of course, similar operations that are pretty resource intensive. You would probably run into the situation that if you would run those queries against a live database, you might actually jeopardize the actual stability of your production system, which is exactly what you would like to avoid. So in order to, on the one side, maintain the stability of the production system, and on the other side, having the capability of actually analyzing these kind of data, you need to do some sort of database replication. So basically, you get the data that you have in your operational database, and you replicate them into some sort of safe environment. So typically, this is represented by some sort of data warehouse, where you invite your data analytics team, and of course, they can run all sorts of queries to find whatever is necessary from the data. Of course, this approach requires of course, depending on the volume, depending on the complexity, depending on your data structure, these volumes actually or these workloads actually represent a quite significant technology challenge, especially when we are talking about your needs for the actual have the data in the real time or in the near real time. We are talking about a large volumes. We are talking about the fact that that perhaps what you would like to capture is not just to replicate all the data, but indeed you just need to replicate the only data that has changed. And this is the exactly reason why you would use this CDC change data capture technology, because this allows you to not do it in the primitive way, meaning that taking full replica from one database and transfer it all around to a new location, which with all the drawbacks that it has, in terms of the overall throughput requirements, the requirement for data processing, but as well as requirements for your networking bill, internet connection bill, data warehousing bills, because if you need to move all the data again and again, where 99% of the data does not have to be moved at all because they don't change, this of course leads to a, let's say, pretty large amounts of inefficiency. And this is the exact reason why you would use the CDC technology. There are other reasons to do so, which we'll not touch today. The second is of course, what can be called as a disaster recovery. So typically, when you need to make sure that there is your data is actually available into multiple physical locations. So in terms of preventing the potential downtime of the primary location, but as well as when you are doing something like system migrations, where you are migrating from one database technology to another, you need to make sure that data are being kept in sync, in this case, in the near real time. And because it's not easy, or whoever ever done any sorts of system migration, he knows that it's fairly difficult to actually do it as a simple switch. So those systems needs to be run in parallel for some time. Therefore, you need to find a way how to actually synchronize the data for some time to make sure that the migration is running smoothly. So now we, let's say, lay down the ground for the CDC. So what is the most common techniques when it comes to using this technology? So let's say, imagine a situation that you have decided, okay, so I have my production data in, let's say, MySQL, and I want to move them into the BigQuery, where I will allow my data analyst to actually play with those data. So what kind of options you have to achieve the CDC? The first, fairly simple, it's what can be called as a query-based CDC. This you can imagine as a very simple select query, where you select a data from a specific table or tables, followed with some where condition, where you will basically say only select those data that has been updated yesterday or has been added yesterday, providing that you have the database schema or the table schema ready for that. This is the very simple solution. Of course, you will do the select query. This will produce some sort of data in the two-dimensional table, and then you will get this table or this tabular data, and you will need to insert them into the new location. Of course, the advantage here is the actual flexibility, because it's in fact a SQL query or any other using any other query language. So it gives you the capability of actually customizing it in the very, very granular way. Of course, this has the implications that you have your table schema already. The second is there is a reduced overhead, meaning that because you have the ability to actually granularly define what you need or what is your select query, you can only really specifically target and easily define what does it mean change for you. And then because it's based on the query, it's On the individual level, it's easy to troubleshoot because it's still again running a query, so it's as complicated as it's inspecting any other database query, so fairly simple. What is the disadvantages? Complex maintenance. That's number one, because imagine that you have a database where you have a couple of hundred tables. And this means that you actually need to have probably the same amount of select queries for that. As I mentioned, it's easier to troubleshoot on the individual level, but maintain it on this large level is a pure nightmare. So this is the trade-off. The second trade-off is the high latency. You cannot achieve a real-time replications using the let's say standard select query, meaning that you would use a select query to select data and then run some insert process. This is typically run as some sort of batch process where you move data in some scheduled time. This might be okay when, for instance, when we are talking for situations where you actually don't need to analyze the data in the real time, or when the real time data doesn't matter. So of course, if you, for instance, need to analyze the customer behavior using the long time series, you probably don't care too much about the real timeliness of the data. So in this case, of course, the latency is not the factor, but there might be of course use cases where it does matter. So this is important to make sure that this is for your consideration. The second approach that can be used, it's log-based CDC. Let's say most of the database technologies that we are using these days, whether it's MySQL, Postgres, SQL Server, Oracle, they have the support for a clustering, meaning that you can run database in the multiple replicas and achieving the high availability. This means that there has to be some protocol that actually allows you to tap into some sort of binary stream of the data and get or use that protocol to actually capture the changes. And this is what is exactly meant by the log-based CDC. So there are multiple technologies like binlog for MySQL, oplog for Mongo, Redilog for Oracle, and others. The advantage is that it has a very, very low latency. So it allows you to do a near real-time application. And really, when the real-timeness is the concern or is important, this is the way to go forward. Also, high fidelity, because if you remember when we were previously talking about the query-based CDC, you cannot capture the deleted rows with the query-based CDC, because once you delete the data from the table, they are no longer there, so you can capture them using the select query. But you can do that using the log-based CDC. So again, if you need to track the delete rows or any other changes that let's say that goes beyond just the recently muted data, log-based CDC is the way forward. Of course, trade-offs or disadvantages, it's quite difficult to implement, and we will be talking about it. We will talk about it at the later stages. Then, of course, the security, because here you really need to give an access to the database transaction log. which of course require a pretty extensive access levels, and of course this might raise some concerns amongst the security personnel in your organization. Also, there is a limited flexibility, because unless you want to do some sort of heavy post-processing of the logs, which of course is something you can do, so unless you want to do that, it captures all the changes to the database. So sometimes you are a little bit more limited in the way of defining what does change actually means for you. So you have actually less flexibility when compared to the query-based CDC. Of course, providing that you don't need to track the deleted rows. And this, of course, gives us to the third option, which is kind of in between those two mentioned. It's trigger-based CDC. Trigger-based CDC is a model where you actually define a trigger that capture the change, and the change typically can be inserted into some specific table, and you are tracking the data or the changes in that specific table. So, of course, the big advantage is that this gives you a complete flexibility, again, to define what does change mean for you, including the deleted rows. So again, if you need to include deleted rows, you need to have the flexibility of, let's say, defining what does change mean for you. This is a good way forward. Also, low latency. Again, it's this means that when you define a trigger, it's actually an event, and of course, events can be processed in the real-time or near real-time conditions. So again, in case you are in a situation where when you need to capture the changes in the real time, this might be a option to consider. The disadvantage is that it is extremely complex and difficult to maintain. If you remember when we were talking about the query-based CDC, so this was typically requiring maintaining the certain amounts of queries that are actually capturing the changes. Here, you need to maintain the trigger. So in case you have a database with 200, 300 tables, you need to capture the changes for all of them. You will probably need to define trigger for each single table. And I guess you can imagine the complexity and the let's say overall maintenance cost of that kind of solution. So now we have defined what is CDC, what is the common approaches. So let's say, what does it mean for you to decide to implement this on your own? In Dataddo, of course, we provide a CDC data pipelines as a natural part of our product. So we have a pretty long understanding of the matter of the problem, but as well as have a pretty good know-how in terms of what does it mean to actually implement it in the let's say large scale solution. So here I would like to share a couple of our learnings that we did when we were developing the connectors with CDC capability for all the different database technology. So when you decide to move forward and you decide, okay, so I want to do this in-house. So first thing that you will come across is the complexity of the technology, especially when you decide to do the log-based CDC. So you have a bin log for MySQL, WAL log for Postgres, read log for Oracle, transactional log for SQL Server, op log for MongoDB, etc., etc. Each of them, although conceptually the same, is implemented a little bit differently. So for instance, when we are talking about binlog for MySQL, it's one large file, and you cannot specify the table when actually interfacing with that. For WAL, for Postgres, it's a little bit more intelligent, so we can actually read the dedicated log for each specific table. But overall, you will probably need to dive deep into the actual low-level parameters of each systems to actually understand how to do the implementation. The second thing, and this actually goes with the overall complexity of the ETL processes, is that you will need to find a way how to actually write or transport the changes from your source database to the target database. So of course, yes, you can implement insert. This is fairly easy, although we know one thing is to insert 10 rows, another thing is to insert 2 million rows, and another thing is to insert 200 millions or even a couple of billions rows. Each of that requires a completely different approaches. Whether you will use a batch insert, whether you will use the load using file, whether you will use a data streaming, each of that has its own, let's say, technology trade-offs and its own way how to approach the technology correctly. Not only that, you will probably need to figure it out how to implement the upserting. So you just want to prevent the duplicities. There might be a cases when because of the bad configuration, because of some technology trade-off, you might get into the situation where you will potentially include the duplicit data. So you will look in a way how to actually implement the upserting. For those who doesn't know, upserting means that you will basically define a virtual key on top of the table, and your system needs to look at based on the definition of the key, which is typically represented by a set of single or sets of columns. And based on that, you will actually find out what has changed. So it means what either needs to be inserted or which of the rows needs to be updated. And then, of course, you will have to implement the delete as well. And here, of course, we are talking about having some fail-safe mechanism where need to make sure that that with the bad implementation, the delete does not fully delete all the data in the target table. I have been talking about the way how to actually transport the data. Then, of course, the other thing is you will definitely need to consider the way how to maintain and run long-running jobs, because, of course, yes, if you are transferring a couple of rows, it's fairly easy, but then in this case you will probably don't need CDC. When you need the CDC, you can expect that the jobs might take a while, and by while I mean tens of minutes or even hours. And of course, this means that there has to be a way how you are able to handle, monitor, maintain those long running jobs. Error handling is let's say the chapter on its own. Again, each of the technology has a different way how they raise the exceptions, how they present you with the errors, and you will need to define a strategy. What would happen if, for instance, the connection failed? Should you retry the connection? Should you, let's say, encapsulate everything into the transactions to make sure that if the transactions fail, you will be able to do a retry mechanism, etc. And the volume, it's chapter on its own again. This is fairly connected with the part about choosing the appropriate technology for actually writing the data itself. So this leads to the last point, and which is how we actually allow our customers to do the CDC-based data pipelines in a no-code way. This is important to mention. So when working with Dataddo, you actually don't need to let's say, understand all those technical nitty-gritties that I have just described. So you can use one of our no-code connectors, where you will simply choose your database technology. You will choose whether you want to use a log-based CDC, like in this case, when I am querying directly the MySQL bin log, or you can use just the standard MySQL connector, where you can write your own query-based CDC. Choose the table, choose the columns that you want to capture, what kind of changes you want to capture, and that's it. Fairly simple and easy. Then, of course, you have the capability of choosing what kind of system you want to, what kind of destination you want to deliver the data. So as you can see, we have these days support pretty much of all the database technology that are on the market these days, whether it's cloud data warehouses like BigQuery, Redshift, Snowflake, Firebolt, and others, but as well as standard SQL databases. So if you want to replicate the data from MySQL to Postgres, or MySQL to SQL Server, or Oracle to MySQL, this is out of the box possible. You will choose the write mode: insert, upsert, delete, truncate, insert. Choose the, in case of upsert, choose based on which column you will actually define the index, and that's it. Then, of course, you have all your flows listed. There is a full logging. There is notification in play. So in case something breaks down, there is some issue, you are being notified. So in case the system, of course, has an automatic retry mechanism in place, but in case something fails, you are being notified. And in case the automatic retry mechanism is not successful, in terms of, for instance, your source system is down and the connection cannot be established within the next few hours, then of course you will need to do some sort of manual action. But what is important, that you have one place from which you can manage everything. And the nice thing that I would like to mention also is that there is a automated data quality checks in place. So we give you the capability out of the box to actually scan for potential null values, zero values, anomalies, in case that you are working in the environment where you have a high demand for data quality. And so you can set the system in a way that in case it will detect some null values, all the flows, as we call it, to target destinations are being blocked, because this would for you mean that this is a sign of bad data quality. And of course, there is a lot of batteries included. So it's Dataddo is fully software as a service. So no installation, no infrastructure maintenance, everything is cloud-based and everything is ready to use and auto-scalable. Can be configured via UI, REST API, or for those who actually like to have only configuration in the code, we have a Terraform provider as well. We are fully SOC2 type certified. So whatever product you will build on us or whatever data you will transfer, it's actually under this certification. And I have already mentioned the monitoring, notifications, and anomaly detection in case something goes wrong. So we have a last minute of our webinar. So I see that there is no questions. So hope everything was clear. And in case you are of course interested in some offline conversation, or you are just watching it from the record, you can reach out to me to my email address, which you can see on the screen. And of course, I will be more than happy to answer all the questions around not only CDC-based data pipelines. And of course, thanks a lot for joining today's webinar. Thanks a lot for participating, and see you next time.